So these math book problems of the day, they're written by the students in the class, and they do their things in a little bit different order than we do them in, so we weren't able to do all the questions. But there's 25 questions here, and that's their homework over break. Sorry. So it's just due the Monday we get back from break, 25 multiple choice questions, and just do like, a couple problems a day, and it's not that big of a deal, okay? Don't save it till the last second though, because you'll do a bad job at it. And it's really just to help you. Okay, so that's that. The test. Okay, so I could do this any way you want. But first, which question do you think the most people got wrong?
9, basic.
That's incorrect.
The one that.
I was actually really surprised. It's actually number 11, day 1. So let's do that question first. There were 9 people who got that wrong out of 11.
Yeah, I got that. I got that.
So actually, I don't really know what's so hard about this question. So it says,
I didn't get that.
so here's what it says. It says, at what value of h is the rate of increase of radical h twice the rate of increase of h? Okay, so what does rate of increase mean? Derivative. Just means derivative, right? So it means d dt, this is what they're saying. The rate of increase at radical h is equal to twice the rate of increase at h, right? That's what they're saying. So if you just solve this, this side, the left side, is really 1/2 h to the negative 1/2 times dh dt. Right? I'm using implicit differentiation or related rates type stuff. And then this side is just going to be 2 times dh dt. They just want to know what value of h makes this true. That's it. These cancel. So you get 1 over 2 radical h equals 2. So 4 radical h equals 1 if you cross multiply. Radical h equals 1/4, and h is 1/16. That's it. I thought that wasn't that hard of a question, but maybe it's a little confusing the way it was worded. But like I said, I took every question off both days of this test off of one exam, one practice exam. All the questions were off the same exam. So I just wrote it just as it was written. Does that make sense? That doesn't seem that hard now that you look at it, right? Okay, so I guess I'll answer it. I mean, I went through and I went through each question and like who got, or how many people got each question wrong. And nothing like pops out. There's several questions where 7 or 8 people got them wrong. But we'll just spend the rest of the period. I'll answer any questions you want me to answer. Yeah.
Could you do the short answer from yesterday?
Yes.
Is that the last one?
Yeah.
Yeah.
So number 11, yesterday. Okay, so they're giving you a picture of a parabola whose equation is y equals x minus x squared over 500. All right, and then at the same time, in the same graph, you have a tangent line that kind of looks like this. This is the point Q. This point has coordinates 0, 20. And this is point P. And this is line out. Okay, so for part A, the question says find the coordinates of point Q. Okay, so we know several things about line L. First of all, we know that it passes through the point 0, 20, right? So L has a point 0, 20. And we also know the slope of line L, kind of, it's the derivative of this function at the x coordinate of this point, whatever that might be. Let's say that's like point A or something like that. Okay, that's what we're trying to find. We're trying to find A, all right? So we know that the slope of this line is y prime of A, which is really going to be y prime at I'm doing this in a weird way. So y prime would be 1 minus 2x over 500, right? Which is 1 minus x over 250. So this would be 1 minus a over 250. Everybody okay with that? Okay. So I can do the point slope formula here. I can say y minus 20 equals m 1 minus a over 250 times x minus 0. And I know that this point right here has to be on the curve, right? So this point, I could say has coordinates a, comma, a minus a squared over 500. Right, those are the coordinates of that point. I could plug those points in for x and y, and then solve for a. That's all you need to do. I know it's a little bit complicated. This is an actual question, by the way, from the 1996 calculus AP exam. So this would be a minus a squared over 500 minus 20 equals 1 minus a over 250 times a.
I've been doing this with their calculators back then.
So this would be, some stuff canceled. So this would be a minus a squared over 500 minus 20 equals a minus a squared over 250. So you can subtract a from both sides. That cancels. And this is really, this term right here is really 2a squared over 500. So if you were to add that to both sides, you get a squared over 500. Because it's negative a squared over 500 plus 2a squared over 500. So they simplify, equals 20. So a squared equals 10,000. And a is 100. Okay. That was kind of the hardest part about this problem. So that part was worth 3 points actually, out of 9. Part B, I think the rest of the problem is pretty straightforward. Part B, it says write an equation for line L. Okay, so if this point right here has coordinates, I know now it's 100, comma, you can find the y coordinate just by substituting in 100 into this formula and you get 80. All right, and you can also calculate its slope. The slope of this line would just be y prime of 100, which would be 1 minus 200 over 500, 2/5, which is 3/5. So the equation of the line would be y minus 80 equals 3/5 times x minus 100. That's it, and that's worth 2 points out of 9. Is that okay? Everybody understand? Once you find 100, the rest of the questions are pretty easy. Part C says you got this tree growing at the top of the hill, like this, and you just want to know is the spotlight touching the tree at all? So really what you need to know is figure out what the y coordinate is on the line, figure out what the y coordinate is on the parabola, and just see if that's 50 feet or less, right? Because if it's less than 50 feet, then the light is shining on the tree. If this distance is greater than 50 feet, then the light's not shining on the tree, right? So the thing you have to do, you can't use your calculator to find the max of that parabola. That's not allowed, right? You're not allowed to use the max find function on your calculator. You have to use calculus. So you have to take this parabola, y equals x minus x squared over 500, and find the max value by doing the first derivative test. Okay? So this would be y prime equals 1 minus x over 250 again. Set it equal to 0, so x over 250 equals equals 1 and x is 250. Do a little first derivative test, even if you're faking it. So my first derivative test is going to look like this. Oh, what do you know? Yep, it's a max. I mean, I know what the graph looks like, so I know that that's what its shape is, but you got to show that you're doing the first derivative test. Okay? So if the max occurs at x equals 250, you just need to find the y coordinate at that point, which would be the y coordinate of 250, which is 250 minus 250 squared over 500. This ends up being 125 feet. So that's the top of the hill, 125 feet above ground level, 0, where the spotlight is. And then you just need to find the y coordinate of this line at 250. So for the line, you would just say y minus 80 equals 3/5 times 250 minus 100. And if you solve for this, you end up with y equals 170. So that's definitely less than 50 feet above the top of the hill, 45 feet above the top of the hill, or 50, yeah, 45 feet above the top of the hill. So the light is shining like 5 feet from the top of the tree. That's the answer. So then you answer the question. So this part of the question was worth 4 points. 2 points for the first derivative test on the parabola, 1 point for the y coordinate of the line, and then 1 point for answering the question correctly. So in all these questions, it's possible to get partial credit, right? I mean, like if you, for example, if you found this answer wrong in part A, got the wrong answer, but then you correctly use that answer in part B to find the equation of the line, you get the 2 points for part B. Okay, and same thing here. If you got the wrong height for the y coordinate here, but then you answered the question correctly and it's consistent with your answer, then you get credit for that. You know what I mean? So don't let the points at the beginning keep you from getting the points at the end. You can do that. Yeah.
So in part A, I just wrote like y prime, and I just like had some scribbles and erased it and stuff. And then I just kind of guessed x equals 100,
Mhm.
and I got a point. Is that point for the correct answer, or is it for the like y prime doing y prime correctly? Well,
Yeah, I think it's because you took the derivative and.
okay, so if you guess, you're gonna get points.
Right, yeah. No.
Okay. I guess I'm 7.4.
All right, what else then? I'll answer any other questions you want on any part of this test.
Number 8 on the first.
Okay. Number 8 on the first test. The number of vertical tangents to the graph. Okay. So what does that mean? If a graph has a vertical tangent, what does that mean in terms of calculus? Yeah, the derivative is undefined, right? So this is a implicit differentiation problem. You just want to find out when the derivative is undefined. So we have y squared equals x minus x cubed. Oh, it's y squared. Oh, you thought it was y?
Yeah, I just
Oh, yeah. So this is 2y prime equals 1 minus 3x squared. Solve for y prime. So y prime equals 1 minus 3x squared over 2y. So in order for this to be undefined, you know that y has to equal 0. But if y equals 0, in the original function, you get 0 equals x minus x cubed. And this definitely has 3 solutions, right? This is x times 1 minus x times 1 plus x. So x equals 0, 1, and negative 1. So there's 3 points at which the derivative is undefined. And they are 0, 0, 1, 0, and negative 1, 0. So that's what the question is asking. Yeah.
7.
Yes. 7. 7 right above this one.
Yeah.
Okay, yeah. It says differential function has values shown in the table. Which of the following is an approximate value of f of 2.1? How do you find an approximation of a derivative? Like here's a function. I know certain points on this function. How would I approximate the derivative at this point right here? Yeah, it's just the slope of that line is an approximation of the derivative at that point. So it's going to be f of 2.2 minus f of 2.0 over 2.2 minus 2.0. That's the answer. So it ends up being 17 tenths. If you do this out, which is 1.7.
6 on this.
Okay, maximum value of a function. How do you find the maximum value of a function? First derivative test. So we have f of x equals x e to the negative x. F prime of x is the first times the derivative of the second plus the second times the derivative of the first. Set it equal to 0. What should you do to solve this equation? Common factor, e to the negative x times negative x plus 1. So this is only true when x equals negative 1. If you do a little first derivative test on it, here's negative 1.
That's one actually equals 1, not negative.
Thanks. Yeah, you're right. So this ends up being, if you substitute in 0, this is positive, and if you substitute in 2, this is negative. So the max occurs at 1, but the question says, what's the maximum value? It doesn't say where does it occur, right? So you have to actually find f of 1 to answer this question. Okay. So f of 1 would be 1 times e. Oh, sorry, not 1 times e, e to the negative 1, so it's 1 over e.
Okay.
That's a common trick. They try and fool people like that all the time, and it works.
Yep.
What else?
10.
10 on the first part, the second part? Okay, so 10 on the first part. Tangent line approximation to estimate the value of a function. So remember, the deal here is if you have a function and you're trying to estimate this value using this tangent line, it means this value on the tangent line is an approximate value of that value as the function. You know what I mean? So, all right, so we have this curve, x squared plus x tangent y equals 27. And we know it passes through the point 3, 0. And it says, use the tangent line approximation at this point to estimate the value of y at 3.1. So you need to find a derivative in order to have a slope of the line, right? This is the point on the line, 3, 0. This is x equals 3.1. So the derivative, implicit differentiation, this would be 2x plus, it's a product, the first times the derivative of the second, plus the second, times the derivative of the first, 0. So then y prime equals, this is 3, oh no, I can't find my notes. What am I doing? Sorry. 2x plus x. Okay. So this is going to be y prime equals, trying to like skip steps. This is going to be negative tangent y minus 2x over x secant squared y. Did I mess up?
On the original equation you wrote down should be x cubed.
Oh, really?
Yeah.
Okay. So this would be 3x squared. Thanks.
What is this guy doing?
I don't know. Does everyone agree that's the derivative? I think that's right. Maybe. Maybe not. So this ends up being negative tangent 0 minus 3 times 3 squared, which is 27, over 3 times secant squared of 0, which is the reciprocal of cosine, so this is 1. So this is negative 27 thirds, so negative 9. That's the slope of the line. So this would be, the equation of the line is y minus 0 equals negative 9 times x minus 3. Now you just have to substitute in 3.1 in here to get the tangent line approximation. So y equals negative 9 times 0.1, which is negative 0.9. So to speak. Remember, these non-calculator questions, so the first day's test, are designed to be about 2 minutes per problem. That's what you have on average. A question like this might take a little longer than 2 minutes, but then there's some questions that you can answer super quickly. So it's like a bank, you save a little money here and then you spend it there, but you have to really kind of watch your time. Did anybody finish both days like totally feeling comfortable with the amount of time they had? So that's what I'm talking about. Like it's really written so that very few people finish comfortably. So you got to get used to that feeling, kind of do the ones that you know you can get points on, and sort of write off some that you really don't know what they're talking about. And just, you got to it's sort of like a little bit of strategy involved in just how to take the test, because that's how it feels when you're taking it. It's just really overwhelming a lot of stuff, You get used to it. You guys will do better. This was the first practice we've done, and I thought it was okay. I mean, overall on both days, there were 5 people that got a 5, 3 people got 4s, and 3 people got less than that. So I'll just leave it at that. But we'll do better. Like every time you do one of these, like you'll get better at the process. So. All right, what else?
Can we do the triangle one on yesterday's? Not an 8
Sure. And by the way, if you got a 4 or a 5 on this practice test, you are in excellent shape to get a 5 in the end. I mean, really, because to have it be your first go at it, and you got a 4 or a 5, that's amazing. So really good job. Like I've done practice tests like this in other years, and there was like nobody who got above a 2. So, and people in those classes ended up getting 5s. So I think you guys are doing really well. All right, number 8. This is another one that took a little more time compared to other questions. The calculator-based questions, you have an average of 3 minutes per problem, which might seem weird. You have more problem, you're allowed to use your calculator, or more time, but I think they're harder. I think the calculator questions are harder, so that's why. All right, so it says the hypotenuse AB of a right triangle ABC. Let's draw a picture. So I have the hypotenuse is AB, and it's a right triangle. It says the hypotenuse is 5 feet, and one leg is deep, so this is 5. And they don't say anywhere in the problem that it's changing, so it's always 5. I can substitute in 5. Let's have it be 5. Let's label this like A and this B. So it's the side opposite A and the side opposite B. So it says one leg AC, which is side B, is decreasing at a rate of 2 feet per second. -2. The rate in square feet per second at which the area is changing when AC equals 3, so B equals 3. At the moment in question, we want area prime, right? The rate at which the area is changing. It's a little confusing to use A, I think. So that's the deal, right? So at the moment in question, I also know that A is 4, because this is a 3, 4, 5 triangle, right? And I know that the area is equal to 1/2 base times height, 1/2 A times B. So A prime would be 1/2 A times B prime plus B times 1/2 A prime. So I'm missing A prime. Like, I gotta figure out what A prime is in order to answer this question, right? So I can use the Pythagorean theorem to find the missing value here. I can say A squared plus B squared equals C squared. Or A squared plus B squared. Since C is not changing, I can substitute that in. It's 25. And then just say 2A A prime plus 2B B prime equals 0. Plug in everything I know. This is 2 times 4 times A prime plus 2 times negative 2 times 3 equals 0. And then solve. And you get A prime ends up being 3/2. And then you can just substitute it in down here. So you end up getting 1/2 of 4 times negative 2 plus 3 times 1/2 of 3/2. And if you combine all that stuff, it ends up being negative 7/4. So this was a little bit challenging just because you had to do another related rates problem in order to find the rate that you wanted to find. Yeah, go ahead.
So why can we assume that C prime isn't changing at all, but A prime is?
Because it says the hypotenuse is 5.
Like it's always 5.
Yeah, it doesn't say it's changing. It says that the legs are increasing and decreasing, but it doesn't say that the hypotenuse is changing. Like I said, I copied this problem directly as is, and I agree it's a little questionable, but that's the way it was written. So this is the way to do it. I get it though. I think it is a little
Sus.
sus. All right, what else?
Can you do 10 on this picture?
Probably, yeah.
Probably.
Let's try.
And then I erased it.
It says, this question, I don't understand why anyone got this wrong. Just read the question. If the radius, forget about anything else. Forget you even know calculus. It says if the radius of a sphere is increasing at a constant rate, then the rate of increase of the volume of the sphere is increasing, of course. Doesn't that seem obvious?
Yes.
Okay, so here's how you can do it using calculus. V equals 4/3 pi r cubed. V prime is 4 pi r squared r prime. So they're basically saying if this is a constant positive number because it's increasing, then what is this? It's also a constant positive number. This is r squared, right?
When I took the derivative, I didn't include r prime, so that's why I.
Well, even if you didn't, that's positive as well.
Yeah, but if you square a fraction, that gets smaller.
Yeah,
But it's still positive. V prime is still positive.
Oh, yeah.
We don't care if V prime is increasing or decreasing. We care if V prime is positive or negative, right? We care if V is increasing or decreasing, which means V prime is positive. You get what I'm saying? So this question could have been answered without calculus 10 years ago. Don't you think?
Yeah.
Okay. So this is one where they give you 3 minutes to do that question. You would do this question in 30 seconds and spend that time on number 8. All right, what else? And by the way, 6 people got that question wrong, so don't think that you're
number 5.
Wait, Aiden's raising his hand, go ahead.
Can you do number 3?
Yeah, on the first test or the second test?
The second one.
Number 3, this question was a little tricky, I think. When I first read it, I was like, they can all be true, but it's not. All right, here's the deal. This is F prime. F prime goes like this, and this is F2. So they're asking you when F is continuous and differentiable or whatever, max, min, and the point of inflection at x equals 2. So all these questions have to do with x equals 2, which confused me at first. I didn't read that part of the question when I was trying to do this problem myself, and so I got confused as to why it couldn't have been multiple answers. But the question is saying at x equals 2. So let's just go through them one by one and just kind of debunk why they can't be true. So the first one says f is not continuous. Why is it that can't be true?
It's differentiable.
Yeah, because f is differentiable. This is f prime. Its derivative exists everywhere along this line. Even though there's a corner here and a corner there, that would mean that f double prime doesn't exist. But f prime exists, it's 2, right? This is a semicircle or a quarter circle. So yes, the derivative exists at 2, right? And it equals 2. So if the derivative exists, then it has to be continuous. So that's why A can't be false, or can't be. B, same thing. F is differentiable at 2. The derivative is 2. Does that make sense? Part C, f has a local max. In order to determine where maxes and mins occur, make a first derivative test, or chart. This is what my first derivative chart would look like. 0, 3, positive, negative. That's what my first derivative chart looks like, right? It's positive from 0 all the way to 3. Then it's negative. So the max actually occurs at 3, not at 2. Does that make sense? D, the graph has a point of inflection. Make a second derivative chart. My second derivative chart looks like this. 0, 2, and then like 3 point something, whatever, 3.2 or whatever. And it looks like this. If you look at the second derivative is positive on this interval. Then the second derivative is negative on this interval. And then it's 0, which doesn't really tell us anything, right? So there's definitely a point of inflection at 2. That's why the answer is D. There's a point of inflection. Remember, a point of inflection is a point where the second derivative changes sign and the function exists and is continuous. And we know both those things are true. The second derivative is changing sign, and we know that this function is continuous at 2. So that has to be a point of inflection. F of 2 is positive. We don't know anything about that. If this is the graph of the derivative, remember, multiple functions can have the same derivative. They're just vertical shifts of each other. Maybe this is a maybe f that we're talking about is a vertical shift that's way below the x-axis. So we don't know that that's true. Okay. Anything else?
What about number 2?
On the first test or the second test?
Same page.
Okay. An object moves along a line that has a velocity equal to t cosine t minus ln of t plus 2, where t is between 0 and 10. It says the object achieves its maximum speed when t is approximately what? How is speed related to velocity?
Speed is average velocity.
No?
Absolute value.
Absolute value of velocity, right? It's the magnitude of velocity, which is always positive. So this is a calculator question. I would use the calculator for this question. I would graph this absolute value of this function on that interval and just look at the graph and see where the max occurs. That's it. So remember, to do absolute value on your calculator, it's math, number, and it's choice 1. So the absolute value of t x times cosine x minus ln of x plus 2. I think my calculator might be in degrees right now, so I'm just going to change it to radians. So mode, oh no, it's in radians. Okay, so now I'm going to change the window. I'm going to go from 0 to 10, and then do zoom fit. And you can see the maximum definitely occurs at 9 point something. And so I don't even have to really do anything else except 9 point something. If you wanted to do this, wanted to do this like more analytically instead of using your calculator, you'd have to find the maxes and mins using the first derivative test, and then see which one has the greatest absolute value on that interval, which would be a lot of work. But with a calculator, it's not so much work. Don't forget you have your calculator for the whole calculator section. So it's a little hard to determine at this early stage, like which questions are appropriate for the calculator and which ones aren't, because there's some that definitely are quicker to do without a calculator. But again, as you take more practice tests and do more problems, you'll see the questions that you actually need a calculator for and which ones you don't. Yeah, John, last question.
5,
5 on part 2. This was just a basic integration. You have radical x minus 2 x squared dx. How do we integrate this? Distribute, make it like a polynomial. This ends up being x to the squared plus 1/2 would be 5 halves minus 2x squared. So the answer would be x to the 7 halves times 2 sevenths minus 2x cubed over 3. Let's see. That's it. So this is another one that should just take you just a second and save that time for another problem. All right, so don't forget those math boat problems. Once we get back from break, we'll actually do those problems every day, and we'll just see, like, see if we could go. It could be like a little bell ringer thing that we just do at the beginning of the period. Okay? It also, it says on each question, whether it's calculator or no calculator. At first, they actually write it out, and then as the questions get further along, they just write like NC or C or whatever. Or calculator, no calculator. All right. Have a great break. Thanks.
When the bottom exponent is greater than the top, it's 0. When the top is greater than the bottom. What happens?
No horizontal asymptote.
No, we're not.
And the limit is plus or minus.
And it's the same there.
It's the coefficient.
So stupid. I feel like I've done this way
See you later. Have a great
break. Like, I'm not even.
Thank you.
You too, thanks.
Thank you.
Yeah, thank you. How's it going?